Okay, then hello everyone. Welcome back to the workshop. So my name is Lee Kessner and I'm a postdoc at NUS with Harold Soul's lab. And yes, now we are going to present a challenge, the Arena Challenge, which is actually the first year that we have been using this platform. And I'm going to introduce a little bit about the Arena platform that we have been developing over the past 5 years. And then Woba will present the benchmark and the challenge itself and also announce the winners. Okay, then let's start. So basically, let's go over a little bit the motivation of Arena. So why do we need Arena actually? So there are essentially 4 main problems that we aim to address with it. And now it's stuck. One problem. Oh, well. It's a bit delay. Okay, let's see.
No.
Network problems.
No. Yeah. Yes, I'm sure.
Okay, let's just try
this.
So basically, we all know simulation is very important for development and testing your approaches. And but simulation is very, very complex. You have to have a very realistic simulation. And oftentimes, a lot of things cannot be mimicked correctly. For example, the human behavior, which is very unpredictable. And this of course, we want to try to address. Another thing is, of course, manually creating these environments is a very, very tedious process and it's cost intensive, especially if you want to have a very realistic simulation. But at the same time, it's very essential to have a realistic simulation to test your approaches before you can deploy them on a real robot. And so there will always be a scalability versus realism trade-off, which we want to address. And another thing is also like the conversion of 2D environments to 3D, which is, for example, used in photorealistic simulations. It's also a tedious process. Okay, so basically here we can see the modules of the Arena platform. It's not loading. It's okay. There we go. Basically, we have 3 main modules. The first one is you create your map and the world. Basically, you have randomized world generation. We can generate a lot of randomized worlds, indoor and outdoor. And or you can also have a predefined map. For example, we have our NUS campus, or we have warehouses which we use from open source repositories, and then you can import them into our simulator, and then you can test your approaches. Another very essential module is, of course, the crowd simulation, because as I said, in social navigation, you need a very realistic simulation of human behavior, and therefore we also integrated a lot of different social force points. Yeah, and the very, very nice thing is we also have the abstraction over 3 different simulators. 2D, we have Gazebo and Unity, and with our latest edition, we also have ICRA. Yeah. So here's like a short overview of the Arena. It's just some sort of history. Like the first version, it contained only a 2D simulation, and then gradually we just added different simulators. And actually, next month we will present the 5th version, which will add the ICRA sim into our framework. Okay, with that, I want to give it to Ova to introduce the benchmark itself and announce the winners of our competition. So we use this platform to start the competition. A bunch of authors integrate their planners and using our platform. And yeah, Ova.
Thank you. Hey everyone. So yeah, let's talk about the actual competition. And I'd like to start off with reviewing the metrics we use for evaluating the planners. So broadly, our Arena evaluation platform has 4 categories of metrics, which are pure performance, naturalness of movements, social interaction, and human discomfort. for the purposes of our benchmark, since social interaction depends many times on the use case, for example, a caregiver robot should be seen by humans and logistical robot should not be seen by humans. We exclude this category here. And then the split was pretty clear. We have a 50-50 split between the pure performance metrics, very similar to the barn challenge, and the human discomfort metrics, which are mostly based on time in intimate space and max velocity in intimate space of humans, with an additional penalty applied for unnatural movements, such as adding topological complexity by running loops, self-intersecting paths, or standing around idling for more than 5 seconds at a time. Let's talk about the planners. And I'm sorry, I have to be personal for a few minutes here. While looking for planners to integrate into a platform and to benchmark, we've encountered many times these problems, that the weights are unavailable, that the installation process is outdated or broken, that it depends in 2025 on Python 3.8. And I broadly generalize these as limited reproducibility, so that I'm sure the planner worked at some point, but it doesn't work in 2025. Which leads it to us to fix it. And then oftentimes sim-to-real deployment is not documented or not intended by the authors, and the code can be just very messy, which we classify as tedious deployment. But the good thing is this is not only the fault of the authors, it's also the fault of a system that doesn't encourage clean coding practices, and a system which, for example, Navigation 2 doesn't have a native interface for integrating Python policies, which forces authors to re-implement their policies in C++, huge barrier to entry. That's why we introduced nav2py, which is a framework for integrating native Python planners into the Navigation 2 stack. I'm going to be technical for a minute here, and then we can actually get to the competition. So the goal here is for the authors of the paper to integrate their planner or controller right here. It's in the Python section, and the rest of the system is mostly handled by nav2py. What the author is required to do is to set up a virtual environment that is actually reproducible and not just a loose list of requirements.txt, but actually PyProject file with the appropriate dependencies. And then on C++ side, just have some basic calls using our macros to forward, for example, LiDAR data and then send back CMD-val data. And if you're interested in using this framework, we're going to release it next month. And that's the QR code to sign up for an email list. I'm going to send you an email once we release it. We have successfully tested it with the current planners, and we hope that it will make a big change in planner development. Yeah, advantages are reproducible ROS2 and Python packages, works every time, works across different devices. And we have implicit sim-to-real. Like if it works with nav2, you can also deploy it on a real robot all of the time. So I hope this will greatly improve the odds of actually integrating and using a planner. Because ultimately, a planner is only as useful as it is useful to other people, like how other people can use it. If it works for you, great. But in my opinion, that's just an okay paper, not a great one. Okay. Based on these previous problems that I've described, we have come up with 3 finalists that are benchmarked against the baseline DWB planner, which are the original CrowdNav paper, which are DRL-VO, and which is SICNav, which I believe will be presented here later today, actually. Yeah, so these are fully qualified. These work with our framework. These have all the dependencies met, actually able to be reproduced. Congratulations on making it here. I'm very proud of you all. Okay, so where are these finalists evaluated? Let's talk about our scenarios, which Lynn just hinted at with our platform. So first scenario is doorways, where pedestrians walk into one direction or both directions through a doorway, and the robot is supposed to cross at the same time or after them. We evaluated this with 3, 4, and 5 pedestrians and different flow patterns. And as you can see, these are just blatantly flagging doors in a hotel lobby. Then, big scenario is hospital. This is very application specific or like very environmental scenario where we have a fully modeled hospital with different types of people walking around. We test the scenarios with 5, 10, and 15 people in predetermined locations. And here we have different social situations, which is a normal situation where the pedestrians just walk around and perform their duties. An evacuation scenario where the pedestrians, as you can see, start walking out towards the exit. And finally, an evacuation panic where the pedestrians are not so calm and start running around and moving around erratically. And finally, to showcase our role generation capabilities, we also have an empty map that is dynamically populated with 0, 5, 10, or 15 pedestrians. And on that map, we generate a room layout. We're using ArenaGen that adds random static obstacles into those rooms. Okay. So, robot drumroll. Who's excited for the competition winner? The winner is DRLVO. Congratulations. Unfortunately, the author is not here today, which is a shame, but please contact us for your reward. Oh, okay, we already contacted them. Okay. So below you can see the table of the relative scores. You might have taken a look at the formulas in our metrics slide. These are relative formulas, so this relative performance of the planets against each other. And you can see it was a pretty close call with SICNet just coming in a little short. And maybe there's some room for improvement and people can further improve their planners. So the overview of the main metrics, core metrics, these are bar plots with confidence intervals. And you can see that DRLVO mostly outperforms the others, even sometimes for the time to reach goal, the classic planner. And yeah, we thank you for your attention. If you're interested in the upcoming Arena 4 release, please scan this QR code. I'll send you an email. You can register via the form. That will include the roles, robots, benchmarks, and assets used in this competition. So you're free to reproduce it if you'd like. And as promised, I'm here with my laptop with Arena 4 set up. If anyone wants to see the live demo later, please come by my page. Thank you, everyone.